Well, I'd like to welcome everyone to the SEMA Collision Repair and Refinish stage. And today we're going to be talking about the EV Summit that we did and development of the ICAR best practice on high voltage disconnect and initialization.
Yeah, thank you, Scott. Good morning, everybody. My name is Dirk. I'm glad to be here and super motivated to talk about my favorite subject, electric vehicles, and the disconnecting procedure we developed with the industry and got actually vetted over a couple of different stages to get it really approved by everybody. And I think we have a bulletproof document what helps the industry to understand what is the steps to disconnect a vehicle and be as safe as possible and make sure the integrity of the vehicle is really intact and stuff like that. So we will talk about different measurements. We will talk about isolation and bonding testing and how that works and what disconnecting procedure is available when we're looking overall on the manufacturer. So good stuff coming up, and thank you for inviting me to that.
Yeah, and so the best practice is something we've been doing for quite a while, where we bring together all different industry stakeholders and have a technical discussion and come up with some best practices. And kind of one of the underlying things for all of these best practices is that it's the industry that developed it. So we just facilitate the conversation, but we really let the industry drive that. So back in May of this year, we met with SMEs from vehicle makers, collision repairers, insurers, and had this technical discussion and developed this document that we're going to go into a little bit of detail on here.
Mm-hmm. Scott, let me move step back a little bit. And the reason why I say let's step back is, so the question what I would have is, there are OE disconnecting procedures, service procedures in place at every manufacturer on their service information. So why the hell, I'm sorry for that word, you will develop an additional document? And that's maybe the question what we have to answer first. And the reason why not only we, the whole industry felt we needed a document what supports this service disconnecting procedures of the manufacturers is clearly that those procedures by a manufacturer is always developed in an event of a service. So the vehicle comes in for any service work and it has to be disconnected. Now we have a different scenario than we are working in the collision industry. So it means the vehicle comes not in for a service, it comes in with a major problem. And that major problem has the outcome or the risks are completely different. And that's the reason why the industry felt it is needed to have a document what works aside with the manufacturer service procedure or disconnecting procedure to help understanding this much better. And what I see as well when I'm going on those service informations is really often, you have hyperlinks. They love hyperlinks. And hyperlinks are great, but hyperlinks can confuse. And I think we need here a little more a red line to follow what is really clear, that you don't miss a step. You miss a step on a high voltage vehicle, then 400 volts. I know welding is also, you need a lot of power, but 400 volts kill you. So we don't want that anybody get hurt, and technician safety is the most important thing for ICAR, and that's the reason we were supporting the industry with that document.
Yeah. Well, and you had brought to our attention the European regulation that this is kind of based off of, that really kind of was a guiding starting point for us to develop this.
Yeah. If everybody can possibly hear, I have a little accent, and this accent is not from Texas, it's from Germany. And the good part on that is that I grew up in European regulations. I'm not a big fan of regulations, and that's maybe the case that I'm living in the US. But on the other hand, regulations in an important subject like electric vehicles and high voltage technology is, in my opinion, important, It helps to understand. It gives guidelines. It gives you numbers, basic numbers. What is the expected insulation resistance at this vehicle? And that's all summarized in this document, what is called ECER 100, so European regulations. And as you said, I'm from Germany, or I said I'm from Germany, so you have to compare Europe a little bit like the United States. You have the US as a federal, and then you have states where you have state-wide regulations as well. So Germany is the same. You have the European regulations above, and then you have state country regulations like Germany and the UK. So the German regulations is the strongest regulation in the world right now when it comes to who is allowed to work on electric vehicles, what kind of education has to have the technician, etc. And the European manufacturers all follow with their training the German regulations. And they're rolling their training out worldwide. So it doesn't matter if they train somebody in China or they're here in the US, they're using the same curriculum, what makes totally sense. So that's one of the reasons we said we piggyback on these regulations and we use this as a base and modifying this towards the collision industry. That's the big deal here.
Yeah. So let's get into it now. So at the very first part of the document, we call out the fact that you need the OEM procedure. So this never takes place of the actual OE procedure. It's always used in conjunction with. And so in the very first part of the document, we call that out because we're dealing with something where, the high voltage is always inside the battery. We never want our technicians to be working under live conditions because that's not the level of training that they're going to have. So this is something where we want to get that power insulated or isolated inside the high voltage battery, and that if there's anything beyond that, that's when we have a problem.
I have to correct you a little bit, okay? I'm sorry, Scott, for doing this with you, but when we say the high voltage is always inside the battery. We have in an electric vehicle two sources of battery store or energy storage. It's the high voltage battery and that's capacitors in the system. Capacitors will be most likely in the inverter. They can be in a DC-DC converter. In different components are capacitors, and a capacitor is nothing else as a storage device as well. So that means when you have a running vehicle with 400 volts, you charge up those capacitors at 400 volts, and they can kill you as well. So battery is one side, system side with inverter and all the other components are also important to really make sure in the disconnecting procedure that they are discharged and that you are safe.
So when we start going through it, one of the first things that we call out is a note on here. It's just the PPE. So you have to have the correct protective gear on before you start any of this stuff, before you do any touching of any of these high voltage components.
Yeah. So my colleague and friend Jeff Poole said one thing: the unknown is what kills you. And I never forget this sentence, then I love that sentence. And when you come in a situation, in an accident-involved electric vehicle, we talk now about an unknown situation. Then we don't know how is the integrity of the whole system. And to find that out, we have to disconnect it. That's the first thing, disconnect and then make proper testing to check everything is in place. So to disconnect this, we go over this disconnecting procedure in a minute, but there's different steps. But what I have to do most likely is pull something, a battery disconnect most likely. So when I pull a battery disconnect, I don't know what's happened. And for that, PPE, better safe than sorry, better you are overprotected as underprotected. So that's really an important thing.
Yeah, and we go through in the document, and we're detailing even some pretty small details that you have to pay attention to. Like, I know one thing that you've always been pretty adamant about is making sure that the charging cable is unplugged before you start working on this vehicle.
Yeah, we had yesterday on CIC a presentation from a gentleman, and he was talking about electric vehicles and made a little bit gave attention to such basic things. And what he did, and I thought, holy this is crazy what he did. So he disconnected the vehicle and he put the charger in. So he wanted to find out how the vehicle reacts on that. So you have to imagine, I will now circle a little bit around this to give more technical understanding what happens here. So when you, in the battery are battery connectors. These battery connectors open and close all the time. For example, ignition off, battery connectors open, high voltage system is technically disconnected. You make ignition, connectors close, high voltage system is powering up and can support inverter and electric motor to run. Simple as that. So when you park your vehicle outside and you put it on a charging station, in the first moment you take off your ignition. I'm sorry, I was looking for the word ignition. Then next time you have to help me by when something like that happens. So you take off ignition and connectors in the battery will open up. So now we put our charger outside in. So to charge the battery we need closed connectors to be capable to bring power to the battery to charge it. Okay, so every time the car is somewhere outside of this building on a charging station, the vehicle is really live. It's under live conditions. So when the technician now works on this vehicle, first thing, unplug this charger. Then we don't want to work under live conditions. Then this is a live threatened situation. So that's how you have to know. So now this gentleman who said yesterday, oh yeah, I tried out to plug in the charger and the system was disconnected and want to see what happens. He said, hey, they were like flagging all codes. He had problems to erase them. So this is a dangerous situation, what you should not do. So I was not happy that he even talked about it. And I like, holy, don't say things like that was in my mind. So really think. So thank you for pointing out the charger.
Yeah, and I think that's one of the things that, collision industry, we've killed a lot of 12-volt batteries because we have doors off and things disconnected. And so we've kind of been conditioned that, if you're going to have it, you have to at least have the battery disconnected or have some kind of battery maintainer on it. And if that same process follows through on an EV, now it becomes a much larger problem.
Yeah, absolute. And let's talk a little bit more about the steps you have here listed on the PowerPoint. First step is, of course, I will leave out a couple of those steps. So I don't want to go over it and we're sitting here until tomorrow. So the first step, what you have to do is to remove your battery charger. You have to, of course, block out, check out the area that nobody walks in there who is not allowed to be in there. That's really basic, important stuff. You choke the tires, that the tire can't rotate. Then when the tire technically is rotating, our electric motor will recuperate and will produce energy. So that's could be also dangerous. So don't do this. Another really important thing is then to say, okay, now let's really start and focus on the procedure. For a certified disconnecting procedure, you have to minimum shut off 2 systems. So system number 1 is technically ignition. System number 2 would be, next step, 12-volt battery. When you remove the 12-volt battery, the control units are not capable of communicating anymore and the system is disconnected. It's open. So that would be technically enough. But are we good with enough? No. We want to make sure it is really. So next step is what disconnect we have. Battery disconnect, service disconnect, or whatever. So, and this is exactly in those 3 different methods you have here listed. Battery, service, diagnostic tool disconnect. The steps, how you go about it is always a little different. So ignition, yeah, but when you have a diagnostic tool, there's not the ignition as the first step. There is the tool the first step, then you need ignition to operate the tool. So that the where we're starting is a little bit different. So, and that's really way good laid out in this document.
Yeah, and I think that's the important part is that, we're taking into account all the different methods that you might run into, and you're still going to need that OEM specific step-by-step part of it, but it's going to be one of these three types of processes. And so that's why all three are in that document, just to kind of make sure that there's always a consistent way and method about going about. It's no different than if you're going to be how you sand a part and the steps you have to take to sand it with the different grits. It's the same thing here. You have to follow all the same steps each time to make sure that it's done correctly.
Absolutely, yeah, and and labeling. You have here one of those labels we created here in the picture is really important as well. A lot of people think, that's a detail I can, but to say I disconnected this part, I removed the battery disconnect, and I did this place. This is the battery disconnect. It was today. My name and my phone number. When somebody has questions, then maybe I'm not around this vehicle, and how many days the vehicle stands in a collision shop? A week? So that somebody knows, Dirk did this job, I have a question, I can give him a call, I can ask those questions. This is really important. Bart says always communication is most important. Also here, we have to know and who did this job and why and what is the reason for it, that everybody knows it. So, when you follow one of those disconnecting procedure, what the vehicle has equipped with, and you pull the battery disconnect, let's say, as the last step, and you think, okay, now it's disconnected. Now I'm good. No, you are not good. You are good when you verify there is no voltage present.
Well, and I think that's more important on collision than even on the service side, because on the service side, there's typically a single fault. We could have multiple faults, damaged wires, unknown conditions that, for the most part, on the service side, they're not going to see on a daily basis.
So what our technicians have to learn when it comes to electric vehicles is a few things. But the most important thing is verification, verification, verification. We talk later about our training. And I know I had you, or I pushed you through this training, that you are capable of talking to me here now.
No, that's true.
So, and I think everybody who goes through this training get a little bit annoyed by I have to do it again. I have to do it again. And what I say is, for verification of, is there zero potential in this moment? So is voltage present, yes or no? New language, what we introduce to our industry, zero potential, means there is no potential present in that system, is really important. So what we're doing is we take a multimeter or a 2-pole voltmeter, one of the recommended tools from the manufacturer, and we want to measure at the disconnecting point, there is zero voltage present in the battery and in the system. Then we open a connector where we have to look both sides. The one side, what makes the capacitor, the other side, what is the going on in the battery. So that's really important. But before you even allowed to do this job and measure, you have to make sure your tool is operating well. And that's what I say, verification. So we go on a known power source. Let's say we go on the 12-volt battery. We verify the tool works and is set up right. And then you go to your measurement point, measure, and then you go back to the known source and verify your tool is still working. And so you check twice the tool before and after. Then we talk about 400-volt systems, what the majority right now runs off. And 400 volts can damage a tool really, really easy. So that's the reason we want to always verifying the result you read on a meter is really true and the meter is still operational. So that's a big pain even for me. I have to do it again. I forgot. So that's always like that game.
Well, and that's one of the things that I think, that repetition is really good, because this is something, like we said, there's kind of the standard operating procedure on how to go about doing this. You're doing it the same way every time. And so there shouldn't be room for error on that. And that's the important part, is that if you're consistent with it, you're going to be consistently safe.
Yeah. And now I want to come to one of my favorite talking points, and this is a multimeter versus a two-pole voltmeter. So what is a two-pole voltmeter? Can you remember? You used it?
It keeps your fingers out of places that are not supposed to be.
Okay, a two-pole voltmeter is nothing else as a voltage tester. This tool can only detect volts, AC and DC. You don't have to switch it to one or the other item. Honestly, I did something last week at home. So I have a crazy electric system at home in my house, and I verified, okay, there is a cable, and I don't know where this cable goes, and it's not powered. And it comes to a big breaker box and so on. And I thought, so how I can find out where this cable is going when it's not powered and nothing? So I put a 9-volt battery on it. And I thought, okay, now I get down in my basement and I measure with my multimeter, I look for those 9 volts where it comes in, and then I know that's my cable. So what I did is I measured first 110 volts AC. And I left my multimeter on AC, and I went down in the basement and looked for those 9 volt, but the 9-volt battery is DC. So, and I was like, I didn't find it. And then I went back up, where's this cable? And then I looked on my meter, and I said, oh, Dirk, this is DC, you have to change your setting. I changed my setting, went in my basement, and I found those 9 volts. So on the AC mode, it didn't show me any voltage. And this is the risk for high voltage technology. You have to think, you have to set up your tool on the right setting to measure things. And that could be a big problem. Then when you make a mistake, you get a reading 0. You think, oh, the world is good, system is good, and you touch the cable and you are dead. So that's the problem. There is no room for mistakes. And that's the reason with a 2-pole voltmeter, you don't do anything. You don't need even a battery to operate that thing. The battery source is the source what you measure, and not a battery inside. A multimeter, the battery could bad, you could make mistakes in the right setting, and the 2-pole voltmeter is like $80. It's not like a huge investment. So this is the number 1 tool for our industry in the future, in my opinion, to stay safe.
Well, and I know one of the things that when we were checking the high voltage to verify that it wasn't there, both your hands are occupied. You can't accidentally put your hand where it's not supposed to go, touch up a connector or something like that, and complete that circuit. So with that 2-pole voltmeter, it also keeps you safe because you can't accidentally put something where it shouldn't be.
Absolute. Okay, so where are we going now? You guide me. I talk. Guide. I talk.
So, so once we've gotten through the vehicle disconnect, everything's verified, and we do all of our repairs. Now we're going to start putting the vehicle back together, and we want to start the process of powering it up. So the first thing we got to do is bonding test.
So, you talk already about powering up. I'm far away from powering up that vehicle. So, let's go back to a repair scenario. In the collision side, vehicle is disconnected. Everything is safe. So now it gets to the repair process. So before components have to be changed. High voltage components have to be changed. The charger port of a lot of vehicles is in the front, in the middle under the manufacturer logo, or on the side. So critical points for an accident. So those things have to be removed and replaced. And when you do this, and I know you guys from the collision really well, you like to put some anti-corrosion stuff on it, and you want to paint, and you do your job as best as possible. So, but now we have to learn things that every high voltage component is bonded against the chassis. And this is one of the safety items of that system. We call it a floating system. In Europe, they call it an IT system. So IT, what the Europeans talking about? IT has nothing to do with computers. It is stands for isolated terror. And terror is ground. So what we have an isolated vehicle, as everybody knows. When we look at this vehicle, that's nothing what connects the vehicle with the ground, and we have rubber tires in between. So there is no, back to my house, There is outside a big stick in the ground. What is my ground connection of the house? That's not present in a system like that. And that's actually good. Then this is the safety side of those systems. So when a component has to be bonded to the chassis, what is a safety requirement? So now let's say Dan Schwartz, my friend over here, I know he's doing a good job. He's one of the most educated guys in the collision industry, in my opinion. He don't know about it, but whatever. So Dan is doing his job and fixing this repair, make a couple of really nice welds, and puts those anti-corrosion over the whole frame and make everything nice. And then he screws this electrical high voltage component against the frame. So now we talk about a bonding issue, possibly. When this component is not bonded properly, then it will be not detected by the own diagnostic system of the vehicle. So an isolation test works always that we're sending voltage over the chassis out, and we check if there is any voltage present in the high voltage system, what should be not there. So when I send the voltage out and I measure it inside the system, then I have a leak, then I have an isolation test. So, but when this component is not bonded properly, and we talk here about milliohm, and this is a new learning curve for our industry. We are used to, 5 ohm cables, I measure that, it's nice. We talk about thousands of ohms now. 1 milliohm, for example, for 1 meter, for 3 feet of cable is an appropriate measurement. So we're going lower than milliohm. And when this is not properly bonded, this isolation test, what I described, will be not happen. This part is excluded, and a fault can be appear. An isolation fault can come, and every component has a danger of an isolation fault. And nobody will find out, then the system can't detect it. And that's dangerous, and that's the reason why for our collision industry is bonding, verification, make sure everything is okay after a repair, extremely important.
Yeah, so in a typical collision repair on a nice engine, you paint over the grounds and things like that. It's Friday, you're trying to deliver the car, things aren't working, nobody gets hurt. Where now, if we have a whole bunch of problems on electric vehicle, because we didn't connect the bonding cables correctly, we didn't check to make sure that it was all actually bonded and isolated, now we have a much bigger problem for that technician.
So we have a huge problem. And the huge problem starts with, for example, also connectors. You know, you open connectors. Those connectors are high quality connectors. They have a lifetime and open and close cycles of like right now between 75 and 125 times. So usually those connectors not getting open and closed 100 times. Nobody's doing this, but they are high quality. So the connector resistance inside between those components is also targeted in less than 1 milliohm. So now I give you a scenario what really can happen and can hurt and can burn down a vehicle. Scott, you moving this vehicle to the paint booth. You make a pretty good paint job. Everything is nice. The vehicle is in there, and the particulars of this paint is floating around and goes inside of those connectors. So to increase in resistance from 1 milliohm to 10 milliohm, this is like nothing. You don't need anything of it. You even would visible see that. So, but what happens when you increase in resistance in a connector from 1 milliohm to 10 milliohm? So I want to say that as well. 1 milliohm is 0.001 ohm. Only to give you a little better understanding what we're talking here. So from 0.001 to 0.01 ohm. That's the change I'm talking about. Measuring this change is only possible with a 4-wire measure method. 4-wire, it means we use 2 wires to apply a measurement current of 1 amp, and we measure voltage And then we take Ohm's law and calculating 1 amp with the measured voltage and getting out resistance. So that's how that works. Okay, I come back to my example, 1 milliohm to 10 milliohm. When you have a 400 volt system, and we will have 400 volts and we have 1 milliohm, and you want to calculate watts, the power, what goes over this connector. You come out with 80 watts. 80 watts, we are up here. I think this is easily a 150 watt light bulb up there. I don't know, pretty bright. But at my house, I have some 80, 90 watts, 90 watts light bulbs. So they can get hot, but they're going through a thin wire. Now we're talking about a wire what is this thick, huge connectors, so no problems. But when we make this calculation and multiply by 10 milliohm, then we're not by 80 watts, we are at 800 watts. When we say 20 milliohms, we are at 1600 watts. When we are at 30 milliohms, were you good in math? So it goes up. And what is 1800 watts in your house? It's your toaster, a good toaster. A freaking fast toaster, by the way, so that's really, really, really an awesome thing. And that gets hot. So now imagine somebody sprays this vehicle, do a great job with everything, a layer of this paint goes in these connectors, he's not recognizing it, put it everything back together, there is no verification, the customer drives this new painted, good-looking vehicle out, drives in Denver where I live up the mountain, full throttle, full power, 400 amps going over this system. And the connector gets hotter and starts melting, and the vehicle starts burning. And that's the cars who's staying on the hard shoulder burning. And everybody in the world knows that in Denver, Colorado, an electric vehicle burned down yesterday. So, and that's the risks, and that's where education is so important, that we say you have to cover those connectors. Paint only a vehicle with covered connectors, that there can't go any dust inside of this connector, debris or whatever you say.
Well, and that's something that's pretty normal for a collision tech on an AC system that's going to be open for a while. But the desiccant might get bad. The compressor might go bad from having contaminants in it, moisture, where you have to replace a part or two. In this case, we burned down the vehicle, and we're talking about overspray, not where you can actually maybe even see it, but that fine mist that you sometimes can only feel on a finish, and that could potentially be all it takes to actually cause a major fire on that vehicle.
So yeah, and I said you need the right testing equipment. So to verify, for example, we stopped at bonding. I was talking a little bit about 4 measurement methods. So there are new tools there. A milliometer is that called. And we need a megaohmeter then for isolation tests. So also for me, the 3 most important tools what our industry, besides the proper PPE, needs is a 2-pole voltmeter, a milliometer, and a megaohmeter. So that's the new world where we are talking about. So, and those tools are not that cheap. So a milliometer runs close to $2,000.
Yeah, but if you're gonna, and that's one of the things that these vehicles, whether or not you love them or hate them, they're coming, and we're gonna have to deal with them. And if 25% of the car park is electric vehicle, you can't just turn those vehicles away because you don't want to understand and work on them. And there's a lot of steps that go into it, but once you understand that process, it definitely can be done in the collision environment.
Absolute. And somehow I start to love those cars. I don't know why, but yeah, I talk so much about it, and I learned in the past so much about those vehicles that I honestly actually think they're much easier than ICE engines, easier in that regards. You do those steps. And honestly, when I disconnect the car, and that's another story what I want to point out. When I disconnect the vehicle, I'm like, my heart rate goes up. All the time. All the time I'm nervous. I have respect. I know what the consequence could be when there is something, when I do a mistake. So my heart rate goes up and I do this. But I think I know really well what I'm doing, and still I don't get this routine, oh yeah, easy, do this. So then we talk to others, and other parts of our industry, they're getting vehicles in, and they say, oh yeah, let's take this out and take this out and this out. And I ask him, did you disconnect those systems? I didn't even know I have to disconnect something. So nobody died. And I don't want to now make those easy. They're not disconnecting it. They're taking parts out there, and the system of those vehicle manufacturers are so safe that we didn't have a major accident. So I say kudos to the manufacturers who make those systems so safe, but please never think, oh yeah, Dirk, the guy on SEMA said, oh, those vehicles are safe, you can rip everything out apart. No, that's not the point. Systems are super safe. I'm always get a little angry when I hear like, oh, Denver, Colorado, there was a burned Tesla or whatever. Hey, there's one car was burned in the whole world in the last 6 months or whatever. How many ICE vehicles were burned in the same time and nobody talks about it. So but this is our world where we're living in regards to news and other stuff. But have respect for those systems. I believe in the integrity of those systems. They are so safe. I got at best case that example what I did, but respect is a good thing.
Yeah, and I think that some of these, like the isolation testing and things like that, we talk about that quite a bit through the training, and it's one of those things that you could have you have to have a lot of bad things happen to that vehicle. A lot of things have to go wrong for somebody to die, but it's already been in a collision, and that's where the most potential to have multiple problems in that system exist. And so that's why we have this best practice that we developed.
Yeah. So that's also the integrity of the system, and the safety features was in there. Interlock loops is there in the bonding, what I was already pointing out. It's important that components are bonded properly. So let's say you are an inverter and you have an isolation fault. That means high voltage leaks against the housing. So, and I'm the technician and come and touch you as an inverter. I will not die. And the reason why is then I didn't close the loop. So let's say the cable is another high voltage component, and this has as well an isolation fault. High voltage leaks to the housing, and I would do this. I would be dead. 400 volts going in my body. So what that means is, that's another good thing. Everybody says to me really often, Dirk, 400 volt kills you. No, 400 volt is not killing me. We're not talking about voltage. Voltage will not kill you. The current is what kills you. And the time, and the question is how long you have this current influence or penetrating your body. So time and current is important. So let's make an Ohm's law example. 400 volts. How much current is that by my body? My body has a body resistance 1,000 ohms. So not mine. Every human body has a resistance what is somehow at around 1,000 ohms. So 400 volts, 1,000 ohm means we have 400 milliamps as a current penetrating my body at that moment. 400 milliamps. Sounds not much. But 400 milliamps will kill you. So we come in a stage where your blood starts boiling immediately, your inner organs will be destroyed, and you will be dead. So when I go back to say 110 last week, I told you my 9-volt battery thing, and then I touched something stupid and I got shocked by 110 volts. It's 110 milliamps what I had to handle at that moment, and it didn't hurt me. Then it was a milliseconds, but when I would hold this cable for a second with 110 milliamps, 110 volts, 110 milliamps, I possibly would be dead. So that second, that time of a second can kill me with 110. But what you do, you get zapped. This is a millisecond. So that's not a big problem. It hurts, don't care. So time and current are the most crucial things when it comes to be what is dangerous and what not. So where are we going now? I know I confused you completely, like always.
No, that was the first time you told me about it.
Oh, okay.
But now that after going through the training course and developing this document with you, it actually makes a lot more sense. And so through this whole process, we put together a document so we can document everything that you did so that you have that for the repair file, that you actually went in and verified at the time what the readings were, what tool it was, and that the tool was functioning.
So, yeah, in our current world, documentation, super important that you really verify and write down what you did, also for future. We had yesterday CIC, and there was twice pointed out that this John Eagle case and other cases are floating around this country currently, and it's really important that technicians and shop owners have their documentation in place. Also over a really, really long time. So we were like saying the average vehicle is right now 12.1 years. That's the average vehicle age right now. So that means you have to store and document your repair informations way, way over 12 years. That was the outcome of this CIC meeting yesterday, and that was the message. So you document here what you did, and then you have also no trouble later when there should be something. The vehicle can be sold to somebody else, from the vehicle owner to owner, but you as the repairer is still your responsibility that you worked and documented everything what you did. And that's the reason we developed this documentation form. And I think I never saw a document like that in the industry before. So that helps really with the service procedure from the manufacturer to write down what you do, what you measured on which point, how is the bonding resistance and all that stuff. And that protects your business at the end of the day. So what's next? Oh, I know. Do you know this guy in the picture here? You know what I don't like on those pictures? The guy has always the hands in his pocket. Huh?
Yeah, that's because he didn't do anything that day.
Yeah, he's only, that's the difference now when you are in this instructor mode. It's your mouth what works and not your hands anymore. But I love working with the hands. So, no, what you can see here is we developed a 5-day high voltage training. So in this 5 days, it's really important that we start working on the electric basic engineering knowledge of each technician. So, and I look over to Dan, and I know Dan now really, really well. And Dan is a guy who likes to learn with his hands. You let him do something, and he understands and can recreate it and can work and experience and learns with experience. So I don't want to train somebody and say, Dan, you have to calculate the discharge of a capacitor when the resistance, we have a 750 ohm resistance parallel to this capacitor. So please start calculating it. And that's how Dan is looking like, huh? No, I want him to build this circuit. And when you see here in the picture this board, with those boards we have the possibility of exactly building this. And that example, what I did is passive, active and passive discharge of capacitors. So our capacitors, what are necessary for the operation of an electric vehicles, has to be discharged. And active discharged is we switching and resistance parallel to the capacitor. And low ohm resistance will discharge a capacitor immediately. So we have an accident. Airbag signal goes out, airbag signals activates the active discharge to open that system and make the vehicle safe. Is this working out every time in an accident? I don't know. The manufacturer don't know. So that's the reason they're putting as well an passive discharge resistor in, what is an high ohm resistor. And that resistor takes possibly 5 minutes to drain the capacitor. So when you see in service information, oh, you pull the disconnect and you wait 5 minutes, that's the discharge time of the passive resistor. So things like that, that's basic electrical engineering knowledge. But it's important that you understand this, why 5 minutes wait time. And that's things what we can train, and we can experiment with those toys here a little bit. And that's really cool. And when I did those classes, I see those guys like laughing and having fun, and they can build something. And they can make mistakes. And mistakes are welcome in this example. Then they're learning out of those mistakes and see and understand those systems better. They're building it and verifying it with their measurements, what they perform. And it's so much fun.
Yeah, and because I went through that for the pilot class, and I think I'm a typical collision repair technician. Electrical was not something that happened. That went over to a mechanic, and just walking through that process, I think really helped prepare a better understanding of that whole process. And I wanted to point out the demonstration cart we have, because those boards you pointed out, I think, really prepared us to even begin to understand this activity.
Yeah. So what you can see here is an electric vehicle cart. It's a prop. It simulates a whole system and whole vehicle. The only thing, it is not driving, so everything else you can do. So what is the cool part is we can put folds on that system. So this bonding, isolation folds, we can pull off folds. And we can't put folds on a live vehicle. This is dangerous, and we don't want to be in a dangerous situation. So with those cards, we have the possibilities to simulate every possible fault on an electric vehicle in a safe environment, and people can train their skills. So really important is we work first on the electric basic engineering knowledge to really make the gap to understand high voltage technology. And then we work actively on those cards with how to disconnect, how you measure, and work on that. And then we transfer this knowledge over to a live vehicle, and we do it on a live vehicle. So that's the steps on this training we implemented. The cool part is we as iCar, we run this training with 14 different manufacturers and 7 insurers actually. And what we got out of a feedback was, wow, that's the training what the industry needs. So we are on an early stage. The car population of electric vehicles in the United States is 1%. In California is 1.5. So we are on the beginning. But this training and this knowledge what our industry needs to really, really work on those vehicles in the future is coming, and it's coming fast. And that's the reason we are ready for it.
Well, and that's, so we have the hands-on portion of it, but we also had these prerequisite courses that we had to go through even before we did the pilot class, and is going to be the expectation for students that would come to that 5-day training.
Right, and the colleagues from the product development team, they were focusing when they were developing this course. The really, really fundamental what they're focused on is technician safety, how to handle those vehicles, what is an EV inspection and handling, and what is the service considerations, damage analysis, and all that stuff, only to help the technicians to understand those systems and how to stay safe and not die. And that's really so important, and I think I went through those courses all. They are great stuff. They are super nice to follow through, and I can only recommend those classes and to everybody out in the industry to take them and learn and get the foundation straight and learn about it, and then get a live training and really learn how to use those tools and perform those important measurements.
So that's it if there's any questions. But Doesn't look like it.
Okay, no
Thank you.
question. Thank you so much, and see you soon.